Until now, we have discussed how static and code analysis and refactoring helps us to improve the internal quality of the software systems. Static code analysis tools such as SpotBugs, PMD, Checkstyle helps us to detect the bugs and improve the design quality and increase the readability without checking the program. So this diagram or figure you are seeing here, it demonstrates how static analysis tools gradually improve the software quality. Initially, the software contains many bugs, poor design, and low readability. So the first tool, SpotBugs, or an older extension named FindBugs, focuses mainly on identifying the programming defects and potentially runtime issues. Next, PMD improves the structural design of the code by detecting bad coding practices and you can say design violations. Finally, Checkstyle enhances the readability and code consistency by enforcing formatting and styling standards. So collectively, these tools contribute to more cleaner and more maintainable and evolution-ready software. Refactoring, on the other hand, restructures the existing code to make it cleaner, maintainable, and easier to evolve. But an important question arises here. What happens after the software is delivered to the customer? Does software development stop after deployment? So the answer is no. In reality, the software continues to change throughout its lifetime. Bugs are fixed, features are enhanced, technology changes, and user requirements evolve continuously. This brings us to two very important concepts in software engineering, that are software maintenance and software evolution. These concepts explain how software survives, adapts, and improves even after deployment. Static code analysis and refactoring are not isolated activities. In fact, they play a crucial role in long-term software maintenance and evolution. A poorly designed system becomes difficult to maintain. Similarly, unreadable code slows down the future development. Good code quality makes the future changes easier and faster. To summarize, the software engineering does not end with deployment. Software systems continuously evolve in response to changing business needs and you can say technological environments. Maintenance ensures stability while evolution ensures growth and adaptability. And techniques like static analysis and refactoring makes this continuous evolution practical and manageable. So once software is released, the work is not finished. In fact, most of the cost of the software happens after delivery. After delivery, all activities are divided into two major categories, like software maintenance or software evolution. All support activities carried out after the delivery of software are called maintenance, to keep the software working correctly, stable in production, and compatible with the environment changes. There are several types of maintenance. First one is corrective maintenance. That means fixing bugs after the release. Example include app crashes when the user uploads large image. This leads to bug fix patch released. Then adaptive maintenance, meaning adapting to changes in the environment. For example, updating software to support maybe new Android version. Then perfective maintenance, that improves the performance or usability. For example, speeding up a search feature or improving the UI layout. Then preventive maintenance, that aims to prevent the future issues. This may include refactoring code to reduce the complexity or, for example, adding logging to detect future failures. Then software evolution, all activities carried out to effect changes in requirements are called software evolution. Key idea is that software evolves because user needs change, business rules change, or technology changes. So software evolution is a process of conducting continuous software engineering. Software is not fixed once built. It is continuously restructured, improved, and extended over time. Example of evolution, for example, consider an application of online banking system. So initially we have balance check and money transfer. So later evolution, UPI payments added, biometric logging added, AI fraud detection added. So this is not just fixing bugs, this is changing system capabilities. Let's test your understanding with a short case study. An online shopping application has been running successfully for 5 years. The company now wants to add a digital wallet payment option. Fix a bug that sometimes calculates the wrong discount. Improve the checkout code by making it cleaner and easier to understand without changing how it works. So, which task is an example of software evolution, software maintenance, and which task is an example of refactoring? So, number one, adding the digital wallet option is software evolution because the software is being enhanced with new functionality to meet the changing business needs. Number two, fixing the incorrect discount calculation is software maintenance, specifically corrective maintenance because we are fixing an existing defect. Number three, cleaning up the checkout code without changing its functionality is refactoring. The goal is to improve the internal structure of the code while preserving its external behavior. Notice how these activities are related but serve different purposes. Evolution focuses on adapting and enhancing the software over time. Maintenance keeps the software reliable and functional. And refactoring improves the code quality to make future maintenance and evolution easier.